Hey everybody, how you doing today? Happy Tuesday. I'm saying Happy Tuesday, but this video is actually meant to be watched sometime during Thanksgiving weekend, because then on Monday and Tuesday we're going to work on story problems in class. But I'm making this video on Tuesday for people who would like to work ahead, so that they can have less work to do over vacation. Well, I have 3 story problems I'd like to share with you. As in every lesson, make sure that you can do these 3 examples, because if you can do these 3 examples before you walk into class on Monday, and I don't mean I watch Elliot do these problems so I understand how to do them. I mean you physically do these 3 problems on your own and use me as your answer checker. But if you can do these 3 problems, you're in a really good spot with the story problems we're going to do next week. Anyway, this is those 3 problems, and I'm going to start just solving them one by one. Number 1, Steve bought a diamond ring for $6,000. If the value of the ring increases at a constant rate of 3.83% per year, how long will it take for the ring to be worth $100,000? I'm looking for a pen right now. Here it is. And here we go. If you notice, this problem sounds very, very similar to the exponential story problems that we were solving last chapter. That's no coincidence. It is the exact same thing. So we're actually not even writing logarithmic equations. We're going to write exponential equations. But then we're going to use logs to solve those exponential equations. Don't forget to identify your variables at the start of the problem. I'm noticing it's increasing 3.83% per year. So x I'm going to have be the number of years. And then y, we seem to keep talking about how much the diamond is worth, or the ring is worth. So we'll say the ring worth, or ring value, cost. They use the word worth. I'm going to use the word worth. All right, and then exponential equation. So all of these equations are going to be of the form y equals a times b to the x. And as you recall from our previous chapter, if x is equal to 0, you just have b to the 0 as 1, so you end up having y equals a. So a is the initial value, which is $6,000, times it's increasing. So if you take 100% and add another 3.83%, you have 103.83%, but then that needs to be converted to a decimal, so 1.0383. So 1.0383 raised to a power of x. That's my exponential equation. How long will it take for the ring to be worth $100,000? Well, that's the y value, the ring worth. So 100,000 equals 6,000 times 1.0383 raised to a power of x. Now, last chapter, when we were doing chapter 5a, we did not know how to solve this equation because we did not know how to solve when the equation had an x up on the exponent. But then we learned logs this chapter, and we learned we could find that value just using logarithms. Now, we cannot change this into log form until it's specifically y equals just b to the x. So I need to move this 6,000 first, because the 6,000 is not to the x power. If I divide both sides by 6,000, let's see, I'm going to do a little side work here. 100,000 divided by 6,000, those 3 zeros cancel out. So 50 over, so it looks like that simplifies to 50 over 3 equals 1.0383 raised to a power of x. Now I go into log form, which would be log of base 1.0383 of 50 over 3 equals x. B to the y equals x. B to the y equals x. And now, this is my exact answer. And so if you're looking for an exact answer, you can answer it like that. But story problems, we don't normally answer with an exact answer. We answer with a decimal approximation. So we show our next step, which is using that change of base. So it becomes log of 50 over 3 divided by log of 1.0383. And these are log base 10s. And at this point, I can put all this into my calculator. Keep it exact. There's no need to do any kind of rounding in the middle here. 50 divided by 3 is 16.6 repeating. And then I take log of that number, and it gives me 1.22. And then I can take that entire decimal, which is on my numerator, and divide it by the stuff on my denominator. So log of 1.0383. Close, close, and I got an answer of 74. So x is approximately 74.855 years. Oh, buddy, I hope you're married a long time so that that wedding ring has a chance to be worth, or engagement ring probably has a chance to be worth $100,000. But anyway, that's the answer to number 1. Let's move on to number 2. All right. Okay, ooh, drug removal out of the body. So it is known that 12% of a certain drug is removed from the body each hour. If 30 milligrams is given at 9 a.m., at what time will exactly 10 milligrams remain? So it appears that X is, we're not doing years like we were in number 1, we're doing hours. So X is the number of hours. And then as the number of hours clicks by, which is your independent variable, the amount of drug in your body, which is dependent on time, so that would have to be your Y. So amount of drug in body. Y equals A times B to the X. We initially had 30 milligrams. And then each hour, 12% is removed. So 100% minus 12%, that's 88%, but then you change that to a decimal, 0.88. So 0.88 raised to the x power. I just realized something. Like in number 1, they didn't tell us when the problem started, so it didn't really, so it's just number of years. But in this one, if we want to know what time, if x is 3, the answer is noon. So it's important to not just say number of hours, but it's number of hours since 9 a.m. All right, and then, so this is my equation, and I want to know when will exactly 10 milligrams remain. So 10 equals 30 times 0.88 raised to a power of x. Now, just like our last problem, I'm going to transfer to log form, but I can't do that until I move this 30 over. If I divide both sides by 30, I get 1/3 equals 0.88 raised to a power of x. I'm going to use the other technique that I taught yesterday to solve this. I'm going to take log of both sides. So log of 1/3 equals log of 0.88 raised to a power of x. Then on this side, where the x is the exponent, I can bring it out front. So x times log of 0.88 equals log of 1/3, which means x is exactly log 1/3 divided by log of 0.88. and that's my exact answer, but of course I want a decimal approximation. So let's see. First I'd go 1 divided by 3, 0.3 repeating, then log of that. So log of the answer gives me that negative number, then divided by log of 0.88, and I get 8. Again, though, this is where you need to be careful, because this is what my calculator says, 8.594 years. But it says at what time will exactly 10 milligrams remain. And when someone says at what time, you don't just say 8.594 hours, you actually give them a specific time. So at this point, I know that it's 8 hours and 0.59, start over, 0.594 blah 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 minutes. So what I do is I subtract 8 from this decimal total, so all I have is the decimal, and it's that many minutes. It's 0.594 hours. But if you're going to transfer something from hours to minutes, you multiply by 60. So if I multiply this entire decimal by 60, I get 35.645. Now, when it says what time, would you actually say number of seconds? No, you wouldn't. So what you'd say is, so it's 8 hours, 35.645 minutes, but you wouldn't answer with a decimal either. You just say, 8 hours 35 minutes or 8 hours 36 minutes. So let's think about this. You want to know when exactly 10 milligrams remain. So if it's 8 hours 35 let's think about this. So if it was just, I'm trying to decide if it's 35 or 36 minutes. So let me think about just this raw decimal. If the answer was 0.5 minutes, it would still be 9 a.m. If it was 0.93 minutes, it would still be 9 a.m. Then once it hits 1 minute, then it would be 9:01. And even at one point, if it was 1.99 minutes, it would still be 9:01. So this looks to me that no matter what, you need to round the decimal down. So I'm looking at 8 hours 35 minutes. And like I said before, this was the number of hours since 9 a.m. So if you go 8 hours since 9 a.m., 9, 10, 11, 12, 1, 2, 3, 4, 5, that's 8 hours. So it's 5 p.m. And it's 35 minutes since 9 a.m. So 5:35 p.m. is the time. Okay, that is number 2. So when you get to the answer, just make sure you're thinking carefully, does this answer make sense? All right. The population of Gruberia, 600,000 in 1980. That's 80 is the start point. If the population grows at a constant rate of 2% per year, we're talking years, so X is going to be the number of years. Number of years since 1980. And I guess we'll assume January 1st of 1980. And as time moves on, the population changes. So Y is population. So Y equals our initial population, 600,000, times it's growing at a rate of 2%, so 1.02 raised to the power of X. And I want to know when this population is going to reach 1 million. So 1 million equals 600,000. times 1.02 to the x. Same thing as the other problems. First divide by 600,000. So a million divided by 600,000, that's just 5/3 equals 1.02 raised to the power of x. I could then change this into log form. So x ends up equaling log base 1.02 of 5/3. That's my exact answer, but I want, we need a real life answer. So if I go log 5/3 divided by log of 1.02, I get approximately, let's see, so I go 5 divided by 3, hit enter, log of that number, hit enter, then divided by log of 1.02, and I got 25.796 years. But we got to make sure we answer the question because they want to know in what year. So, like I said at the beginning of the problem, we should just assume that this is January 1st of 1980. So, even if the decimal is like 0.9, it would still be 1980. So this is one of those situations that you should round down no matter what. So instead of thinking 25.796 years, I would just think 25 years, and it's the number of years since 1980, so 25 years after 1980 is the year 2005. So be careful. This is one of those situations that you must round the decimal down if you're talking in what year. Of course, that's assuming January 1st, which is what we're going to assume on this problem. And I think I'm done. That's that for this lesson. That's story problems. And like I said, before you walk into class on Monday, make sure you feel comfortable with these 3 problems, because if you feel comfortable with these 3 problems, the practice is going to go smoothly, the quiz is going to go smoothly, and the test will go smoothly, at least with story problems. Have yourself a great day and a great Thanksgiving weekend. Gobble, gobble. Bye-bye.